Okay, I'm back. The batteries ran out, so I had to get new batteries. But I just factored this, and I was saying that f of x now is equal to this form of this rational function. I have an asymptote at 6, 1, 2, 3, 4, 5, and 6, and you can just sketch it like this. When it says label everything, it'd be great if you wrote x equals 6 like that. There's also one at -5, so there's -5. And you can show that asymptote like that, x equals -5. Then that is really the restrictions on the domain. So this would be a great time to just say the domain x is an element of all real numbers. That's the shorthand for that. X cannot be equal to 6 or -5. Okay? The range then are the values that come out. And here's where, if you consider this as a contest between the numerator and the denominator, there are x's in two places here, so that's a second degree. There's a second degree polynomial in the numerator. They have the same degree, so in a sense it's a tie and it balances out, and they cancel out, and it's this coefficient that determines the horizontal asymptote. So this boundary here only applies when the function gets really big. Positive infinity or really negative infinity does not apply in the middle region. You can get the function across. Sometimes it'll come up and dip below or whatever, but it's out at the extreme. So this is a very good time to get the calculator. You'll notice I've typed it in only in the top. I've turned the equal sign on only for the top function. So when I hit the graph, I get a pretty clear conception of what that is like. If I want to see the asymptote, I could go back here and I could just go down and I could put in 2, and then when I graph it, you can see there's the asymptote. It looks like it approaches from above, and then it goes through here. It goes to the origin, which I know because when I plug in 0 for x, I get 0 up above, and I do not have it go to 0 down below. So it's going to start here and go like this, hug those asymptotes, comes from up above and comes down here, and does the same thing over here. Okay? The range then, you're going to find all values. If I have a horizontal line, I'll find all values that I can, with the exception of this little gap right in here. So I'll say for the range, f of x is going to be an element of all real numbers. It looks like x can be 0, so it's going to be greater than or equal to 0. Whoops. My function will be less than 0. I'm going to erase that. My range will be equal to or less than 0, or, that's f of x, or it will be greater than 2, but not equal to it. So f of x can be greater than 2. A little bit awkward the way I wrote that, but you can describe it in just plain old ordinary English, and that'll be fine too. Okay? This one now, same type of thing. You want to factor this. You've got 3x squared up above. Factor this down below. Nothing will cancel with this. Oh, sorry. Very good point here. I forgot. My apologies. Remember how we took out this 0? This has got a removable discontinuity right there. That means that this will not be allowed to be equal to 0. So I'm going to take that out. That's the difference between an A and an A plus answer. Okay, just I missed it, you might miss it, but I caught myself thinking about this one not canceling. I remembered that it did cancel here, and I caught it. So that is your removable discontinuity. So label all key parts, removable discontinuity. All right? That does not really change the shape of the function, right, because it canceled. But I cannot have division by 0, because when I plug in 0, I get 0 in the denominator. So my domain then has to also reflect that is 0. All right? So be careful. See how even the best of us can make mistakes. All right. Here we go then. Factor that thing. X plus 4, plus 5, because 4 times 5 makes 20. X minus 4. That plus means that the plus goes with the larger numbers. So same kind of thing. I'm actually going to redraw this axis just to give myself more room. And then from here, I've got positive 4, 1, 2, 3, 4. And again, I'll get a asymptote, vertical asymptote there. If I'd been clever, I would have used this as the negative one, but I wasn't that smart. Here's the negative asymptote at -5. X equals -5 and x equals 4. Same kind of thing as here. We can write the domain. X is an element of all real numbers, but x cannot be 4 or -5. All right? Then horizontal asymptote, again it's a tug of war. Again these agree. They're both x squared, they're both second degree, so the horizontal asymptote is at 3. All right? I've plotted this second equation. I'm going to turn off that equal sign and go down and turn that one on. Then I'll look at this graph, and you can see I'm kind of getting repetitive here. I should have done slight variety. We'll take out that line there should be moved to 3, I think, and you'll see that it's very similar to the last one. It looks like it does not cross that horizontal asymptote of 3. Sometimes these things will come down below and they'll go back up, or they'll go down below and they'll stay below and they'll approach it from below. That'll influence the range that you'll say. But this graph is going to look very similar to the other one. I'm just going to do it shorthand style. It goes through the origin. This time it will contain the origin, and then like this. Okay? So I'm not going to repeat this because of the element of time. I want to keep this video short. I will put it on the answer key that I scan into the computer. Okay, thank you. Okay, well, I forgot to do these last two parts here, B and C, so I'll do it now. What happens to f of x as x gets larger and larger? The way we do this in math is we'll use this little arrow. We'll say as x tends to infinity. Well, f of x, that's this one, f of x, not g of x. But f of x, as x gets larger and larger, you'll see x cubed and x cubed. That's going to be a large number cubed, and they are going to balance out, whereas these parts become irrelevant, really. They are far too small. But if you think about 1,000 times itself 3 times is going to be 1 billion. So it's going to be 2 billion over 1 billion. Those x to the thirds will just cancel out, and this is going to be f of x will then approach 2. That's going to approach the horizontal limit. Basically, it's asking about the right-hand behavior, as it's called. As x gets larger and larger, this function just approaches that horizontal asymptote of 2. But what happens to f of x as x gets closer and closer to 6, but is less than 6? The way we do this mathematically is we say x tends to 6 from the left. So again, oops, I circled the wrong function after telling you it's not g of x. It's this one that it's approaching 2 out here. But as x gets closer and closer to 6 from the left, that's right here. As x gets closer and closer to 6, as x values get closer and closer to this asymptote, you can see it tends towards negative infinity. So f of x, we'll say, approaches negative infinity. All right? On to the next page. It says solve